for the invitation. Hello everybody. As Lars was just introducing, I'm a computer scientist. So I did my PhD in data mining, and the way that you would be familiar with that is whenever you log into Amazon and buy something, they will regularly try to get you to buy other things. And so my PhD was about the algorithm that tries to do that. So now at Cambridge, I'm working on smartphones and working with a variety of other researchers. And the key message of today is that smartphones as a tool for research need not be a tool for closed research anymore. So the aim of my research is to get these tools out there beyond just the scope of academic research, and to get people really engaged to produce great data for research as well as great experiences for people. So to specify that a little bit, some figures: 71% of the UK now owns a smartphone. The audiences that I typically present to, that number is more at 100%, or when I'm in computer science circles, over 100%, because people own more than one. 195 minutes per day is the UK average for smartphone usage. That's according to some marketing study. And this last one, 87%, is the growth in the last few years of just behavior and health monitoring apps. So out of all the apps that are out there, there's huge growth in social networking apps, gaming apps, and so on. But the one that is growing the fastest are the ones that help people think about their health. But in my experience, trying to work with these systems for research brings in a lot of conflict. And it's because there are so many different parties involved. We've got people who we want to study, end users, us as researchers, and finally developers who are developing these systems. So I probably fall into the bottom two categories. And although we all care about data, we all care about data in slightly different ways. So people who use mobile systems or use apps want to know what's in it for them. Researchers want data that is valid and reliable and useful. And developers want to be able to build these systems that produce data and create some value for them in very easy ways. So you can see that oftentimes people have different goals, and so getting these systems in place could be quite a challenge. So I'm going to be talking about two case studies, which is where we've been using these apps, and neither of them have to do with studying students, but I'll close with describing 2 or 3 open studies where we are working with students. But just to step back a little bit, this paper came out in 2012, Jeffrey Miller, I think his name is, where he was talking about the opportunity of using smartphones. And I think he goes on in his paper to say that smartphones are going to revolutionize psychology research as much as the MRI machine did to help look into people's brains. So obviously the theme of today is looking at getting people to contribute data via their smartphones. But the key thing when I was reading all of these papers that I noticed is that this research methodology has made its way into popular culture. So just taking a sample of the apps that I use, I regularly tweet, so I'll be documenting what I'm doing throughout my day on Twitter. This second one is the Swarm or X-Foursquare app, where I'll be documenting where I am, perhaps who I'm with, and maybe what we're doing. I use Instagram to take pictures of things that I see around the day. And even the last time I was in Oxford, I stayed at the Royal Oxford Hotel. So people are just now every day creating these digital footprints by engaging with apps, and they're telling us about their behavior. So it's not really any longer just a research methodology. It's a way of building engagement with people. However, under the hood is where the really exciting things for a computer scientist like me are. So many of you will have a smartphone like this. This is a Samsung Galaxy S3 or S4, if I remember correctly. And all of these modern day smartphones now come jam-packed with a whole bunch of sensors. And the reason for that is to let the phone do some cool, interesting things. So Apparently, the reason why an accelerometer was put into a smartphone the very first time was that so that when you turned your phone sideways, the phone would know that it's sideways and it'd be able to show everything in landscape mode rather than in portrait mode. But every time that device manufacturers have put a new sensor in the device, it hasn't taken researchers very long to figure out that there are some incredible behaviors that they can track using those sensors. So if you carry an accelerometer in your pocket every day, we can get a signal of how physically active you are. Although GPS was originally put into the phone to support mapping and route finding applications, if we have access to GPS, we can trace where you're going throughout the day, how much you're moving, what places you're visiting, and the list goes on. So there's this whole field of ubiquitous computing which has a lot of very exciting literature to read, where every single story is the same, is that there's this new sensor and check out this behavior that we can now monitor using it. So that's, say, the broad picture of the sort of data that we can now collect. And so I'll dive into the two case studies. So the first one is a collaboration between myself and Professor Maskell at the computer lab. And these two names in the middle are researchers in the Department of Psychology. And we started this project, Emotion Sense, a number of years ago. This is now an old screenshot of the website. And when we sat down for the first time, I was basically pitching something very similar to what I've just said in terms of what data we can collect. And the psychologists were saying, well, we're interested in studying well-being and seeing what is it that drives people's feelings of happiness and positive feelings, negative feelings. How does that relate to their everyday life? And so this is a very, very vague thing to try and address. And so what we started was a very protracted series of discussions that led to the design of this app, Emotion Sense. And really what it boils down to is this home screen here, which allows you to do three things. The first one being this big how do you feel button, which leads you down a 10-question survey. And this survey begins with the affect grid, which we saw in the previous talk, something similar, going from negative feelings to positive feelings, low energy feelings to high energy feelings, and of course you just pick a spot on that grid. I'd like to note that when we deployed this app, we couldn't use the word aroused or unaroused because our early users said that they understood something completely different from that. So we then ask questions from the positive and negative affect scale, and finally we can ask some questions about actual behaviors. So what have you been doing, for example, in the last 15 minutes? Then we have this profile section. Profile section is for these trait assessments, and what we put in, we've just put in a variety of different things ranging from your personality to your job satisfaction and so on. And every time that you complete one of these assessments, you will then get scored against some published research results, and you'll get some feedback right away. So when I completed the personality assessment, I scored quite high on emotional stability. That made me feel quite good. And this read button takes you to Wikipedia, to the section in Wikipedia on emotional stability, in case you want to learn a bit more. And finally, we have the emotions button, and that shows you all of the feedback that you have been producing as you've used the app. So the way that the app is structured is around this journey of discovery, whereby when you first download it, the only thing that's available is the time of day feedback. And all that does is that every time you answer an assessment, it'll put your grid answer, I apologize, it's a bit difficult to see, it'll put your grid answer back on a grid and color it in according to the time of day. After 1 week, you can unlock the location feedback, and a week later you can unlock your texting pattern feedback, and say by the time you get to the accelerometer feedback, which is the data I'm talking about today, you will see all of your affect grid answers, but colored in according to how much motion we were detecting from your accelerometer right before you clicked on that grid. So, as Lars mentioned, we decided to go for, we did one small study within the lab, and we had about 70 or so people, And then we decided to try and release this to the public. And just as I was saying, as Lars mentioned, we went to the press office and they sat me down, talked to me for an hour about this research, and then came up with this headline of Cambridge scientists want to put a psychologist in your pocket. And obviously that's not what we were trying to do. We're just trying to put a measurement tool into your pocket and get you to engage with it. But that twist on what we were trying to do was enough to capture people's imagination, and so we got, to date, about 40,000 downloads worldwide. And we have about 2,000 or so active participants per month. And the very curious thing, that this is from early GPS data that we received, is looking at where this app has been installed. And we were certainly surprised by how much interest we got from India. And the best explanation we have for that is that at the time of the press release, there were two people in the project, myself included, who have Indian surnames. And the Indian press tends to look at what the BBC is saying and then rewriting their stories. So that was one of the sort of very curious things. But back to the research. So now we have this data set, and this is one of the very, say, different things about trying to conduct this kind of research, is that I said, look, we can collect all this data. How can we collect all this data? But we didn't begin with saying, why should we collect all this data? So this data collection was not necessarily hypothesis driven. It was driven by, the scale that we wanted to achieve. Because now that we have this data set, it can fit to a variety of different research questions. And this is one of the first ones that we addressed, where this paper published in 2002 was looking at the behavior of very happy people. And they looked at undergraduates, they measured how happy they were, they looked at their behaviors, and then they looked at what are the differences between what happy people are doing and what unhappy people are doing. So we thought this is an interesting area of study that we can apply to our data set. In particular, we get happiness scores by looking at these state assessments, so your mood reported on the grid, your mood reported by the positive-negative affect scale, and then we also get these more trait happiness scores because people unlock their feedback levels by completing satisfaction with life surveys. So we can aggregate those together to get a sense of how happy people are, and that is naturally assuming that happy people are satisfied with their lives and experience a lot of positive emotion, and that unhappy people are dissatisfied with their lives and experience a lot of negative emotion. So, on the other hand, we can then pull in behaviors and start teasing out the differences between happy and unhappy people. And we get behaviors in these two ways. The traditional way, how physically active have you been today? How physically active have you been in the last 15 minutes? And this sensor-driven way. And so this is an example of the data that you will receive from an accelerometer. This is me standing, the three axes of my accelerometer when I'm standing, and this is me cycling furiously in the gym when my phone is in my pocket. And so you get three axes there. So what we did as a very first step was to say, to what extent does this data agree with that data? And so I'll skip the maths, but essentially what we do is we convert all of these three axes of data, these three time series of data, into one number, which represents how physically active you are right now. So you can imagine that this would produce a relatively low number, since it's related to the standard deviation of the signal. We combine all these three to produce a number of how physically active you are. You could imagine it to be a rather large number because the standard deviation is quite high. And we also can get a score from here because we know that running is more physically active than walking, which is more physically active than standing, and so on. And we throw out the other responses. So we found that there's quite a good agreement. And I say quite good because when we ran this analysis in a very controlled setting, we got a much higher score here. And so why did the score drop in the public deployment? It's because we don't really know what people are doing with their smartphones. So my phone could easily be right here, and I'll be walking around, the phone pings, it says, what are you doing? I say, I'm standing, I'm walking, but my phone hasn't detected any physical activity. So that's one big constraint of this method, which is the lack of control that we can have on the passive measurement. So we can then start tying all the pieces of the puzzle together. So when we look at how happy people report their physical activity and how happy they are, we see that there is a relationship emerging, correlational relationship emerging, and when we compare it to all the data that we passively sense from their device, a weaker correlational result emerges. And this is, I don't have, these are the between user results. I don't have any slides for the within user results, but essentially that sort of relationship still holds. That when we detect your phone shaking more, you're then later more likely to report higher levels of positive emotion. So one of the cool things that we can do with this data, though, is we don't have to rely on you answering a question every 10 minutes. We can just grab this data every 10 minutes, or even more fine-grained than that. So without having our participants actually do anything, we can build a profile of what their day looks like. And this is, say, I guess the equivalent of asking a person every 15 minutes how physically active they have been. Except they didn't have to answer anything, they just had to go about their daily lives. And so we can put all this data together and create a profile for you. In this case, this is what looked for about 100 or so people, what all of their profiles look like together, what their typical weekdays look like, and what their typical weekends look like. And you can see these very typical patterns across a lot of these data sets. So there are other data sets that look at transport patterns, and during the week there are peaks around 7, 8 a.m. while people are commuting. During the weekend, people tend to get up later. And so it wasn't a big surprise when these sort of profiles emerged. But the key thing for us was, how does this profile relate to your happiness? And so what we did was we took these profiles for thousands of people, I think approximately 10,000 people, and we put them into this machine learning algorithm. Let me take a quick timeout. How many people have done any machine learning?
Done?
Any, so experience with machine learning. Okay, 1.5. Sorry, this is the problem that I have when I present to non-CS audiences. Okay, so basically we take these profiles and we put them into a statistical algorithm that is asked to produce a number of groups from the data. And those groups all share similarity within groups and are split statistically to be different between groups. And I can provide more details if you need. So this is one of the results of that algorithm. We just feed in 10,000 people's data and it spits out, it says, these are the 3 groups that I found. And so you can see, again, maybe not the best contrast, that the group up at the top are the ones that have very high levels of activity throughout the day. They tend to be quite active throughout the day all the way until about 9, 10 p.m. And the people all the way down here are basically inactive throughout the whole day. So we see very few spikes of activity, and those spikes of activity in no way compare to the top group. So all I did was, after getting these results, I told my psychologist colleague, I said, look, this is which group every individual has been assigned to. And she found that the people in the top group are also the people who are reporting being happier. So the interesting thing here is that this data is completely independent from their self-reports. It doesn't rely on them actually doing anything. Their self-reports are capturing their mood, their feelings. And when you look at them together, it shows this relationship between how active we are in daily life. And note, this is definitely not physical activity in terms of running, and this is just how active you are in your daily life, and your mood. So this is another way, 10 minutes. Okay, so I'll jump ahead. So one of the ways that that this work has been taken forward is I've given a number of talks like this, and we ran into this guy from the public health department who came and told us that what he was trying to do was tackle a behavioral problem, which is trying to quit smoking. And the reason he gave is that quitting smoking is typically associated with curing an addiction. So you can wear a patch, you can take some nicotine replacement therapy, but in practice, a lot of people relapse back into smoking because of their habits. And so there's a lot of evidence that your habits, especially with regard to smoking, are related to your location. And of course, by now, these alarm bells should be ringing. Location, that's something your phone can really easily detect. So can we apply these same techniques to this kind of behavioral intervention? So suffice to say, we just mirrored the emotion sense system. So we have a home screen where people can report smoking, they get a profile just like an emotion sense. Emotion sense has this journey where you can unlock things. The smoking app QSense has a journey that is in 3 stages of quitting smoking. In emotion sense, you can answer questions of the positive and negative affect scale. In QSense, you answer questions related to your mood and your cravings. And I can note, related to the previous discussion, that this craving question did turn out to be an intervention. In emotion sense, you get 2 to 5 random notifications per day. In QSense, you get 2, one at the start of your day, one at the end. And again, this feedback, which was essential for engagement. The main difference is that QSense is trying to do something with this data that it receives. So what it uses is this system that is now, say, very popularly referred to, like when you take out your iPhone, you say, Siri, remind me when I get home to wash the dishes. I don't know what you would ask Siri to do. What's happening under the hood is Siri is putting a virtual perimeter around your home, and then it can detect when your phone passes into this virtual perimeter. So what we do is we take the same system, and every time a person tells us that they're smoking, we create a virtual perimeter around that area. And this is me testing the system. I'm not a smoker, but I reported smoking about 19 times in this area, and you can see these virtual perimeters being built on the interface of the app. And now every time that I cross through this virtual perimeter, the app knows how stressed I reported being in this area. It knows how much craving I reported in this area. It knows how I described this area. I described it as work, for example. And what it can do is it can then match that profile to the cognitive, behavioral therapy database that we have to say this is what the best CBT support that I think would suit you at this moment right now would be. So just to wrap up, I'll go to the very high level view. A number of years ago we described this method as a cycle. So as researchers, we want to monitor people's behavior in order to collect some data. We then want to use that data to try and learn something, maybe to confirm old hypotheses that have been explored at a smaller scale, or to learn new things about how people are living their everyday lives. And then finally, the system really comes to life once you start feeding that data back to try and change their behavior. And now there are a lot of tiny details that really bug me about this work. One of them is the engagement factor drops over time. This is something that we need to address by design. A lot of times our CBT database would quickly run out, and that was because it was written manually. So we've actually reverted to algorithmic approaches for creating these support messages. And finally, we haven't even touched on the data that we received by people rating these CBT messages. The reason why we put it in there was because this is the kind of data I worked with during my PhD, and we wanted to use it to evaluate how useful and relevant this support was. But if you go back to what I said at the beginning, Amazon gets you to rate things for a very particular reason. It's because then they can use it to tailor that content more. So that's hopefully a next step that we're going to be doing. Just to close, I promised I'd say a few words about the work we're doing with students. So the left side of this slide is for any of you who code. The right side is a picture of an app that we have created on top of our system that is just doing this exact same thing that these other apps are doing. Experience sampling, sensor data collection. And right now that's being used in Cambridge to study mood adjustment of students, particularly in this time period of exams. It's being used at the University of Kent to look at how students are expressing their mood online by their tweets and Facebook status updates, but also collecting data about how they are reporting to an app that they feel. It's being used at the University of Maryland to look at student anxiety and in particular related to their calling and texting patterns. Are they calling out to their support network in times of anxiety? And I think I'm missing one. It was just recently used in Poland to study mostly students who have personality problems and say borderline behavioral problems. So as you can see, the number of studies on this system are starting to grow, and one of the things I'd like to invite any of you who are interested in collecting this kind of data, it's very exciting, to get in touch with me. I'd be very happy to set the system up for you guys as well. So with that, that's it. I'm happy to take any of your questions.